2.6 Formalizing Relations and Functions. Your objectives for this section are to determine whether a relation is a function and define the domain and range and use function notation. What we're going to be doing today is taking what you already know with an equation or a linear function, and what we are going to do is, with some new uses of vocab words, we're going to apply that to what you already know. So look at the gray box in the middle of the page. A relation. A relation is a pairing of numbers in one set, called the domain, with numbers in another set, called the range. A relation is often represented as a set of ordered pairs, x, y. In this case, the domain is the set of x values, and the range is the set of y. So your x values, your domains, are your inputs. Your ranges, which are your y, are your outputs. Here's your essential understanding. A function is a special type of a relation in which each value in the domain is paired with exactly one value in the range. You will have already discussed this before about determining whether or not something is a function. So just remember your three vocab words. A relation is just the pairing of numbers in a set. A set, now by the way, if you want to know what a set is going to be written like this. It's kind of like brackets. They're kind of hard to write. You'll get used to writing them. And then your domain are your x values, which are your inputs, and your range are your outputs, which are your y values. So let's look at the got it at the bottom of page 135. So here's what the got it says. Identify the domain and range of each relation. Represent the relation with a mapping diagram. Is the relation a function? Alright, so we first have to identify the domain and range. The domain are your x values. So all you have to do is put your x values within a set. So your domain would be 4.2, 5, 7, and we've already used 4.2 in the last one, so we don't need to write it again. Your range are your y values. Your range are your y values, your outputs. So your range would be 1.5, 2.2, 4.8, and 0. And this is how you'd write it. Domain is in the set 4.2, 5, and 7, and range is the set 1.5, 2.2, 4.8, and 0. Now when we map them, all we have to do is put all of your domains in one box and all of your ranges in the next. And I'm going to label them D and R for domain and range. Now, if we now look at your domain, let's put the 4.2, 5, and 7 within that box. Your range would be 1.5, 2.2, 4.8, and 0. And now to map them, you just draw an arrow from your x value to your y value. So 4.2 gives you 1.5, according to our ordered pairs. 5 gives us 2.2. 7 gives us 4.8. And 4.2 gives us 0. Now if we remember what our function is, a function means we have to have exactly one output for every input. Well, we have a problem here. 4.2 gives us two outputs, which means I cannot have that. Therefore, this is not a function. Now let's look at B. Now I've already done the entire problem. Your domain are your x values, -1, -2, 4, and 7. Your range are your y values, which are 1, 2, -4, and -7. I have put them in my map, and as you see, every one domain gives you one range, so yes, this is a function. Now in the next section, problem 2, it says identifying functions using the vertical line test. Look at the shaded region above that. Another way to decide if a relation is a function is to analyze the graph of the relation using the vertical line test. If any vertical line that you draw passes through more than one point of the graph, then for some domain value there is more than one range. So it is not a function. So all you have to do is draw a vertical line. If at any point in the graph that your line that you draw crosses the graph more than once, it is not a function. So I'm going to just draw a dotted line wherever. So let's just test this. Vertical line, you don't need to write these down. And this is a really bad vertical line. But you notice it's only connecting right here. It crosses once here, it crosses once here. No matter where you cross it, it'll only cross once. So yes, this one is a function. The next one, if you draw a line, you will notice that it goes right through the graph. How many times? Right here and right here, so it's twice. This is not a function. And the last one, you can draw a line straight through it, dotted line, solid line, it doesn't matter. It crosses more than once. This one is also not a function. So it's a really easy test to perform. So now I want you to look at A and B under the got it. All I want you to do in A is just graph those 5 points. On your own, make a little t-table, not t-table, a x and y axis, and graph those points. Now that's what your dots are going to look like. Keep in mind you're not connecting them. You don't have to make a line. This is not making a line. All you have to know is, can I draw a vertical line? A vertical line anywhere where it'll cross through those points more than once. Let's see. Is there anywhere that I'm moving this? Oh, crosses once, crosses once, crosses once, crosses once. Therefore, no matter where I put it, it only crosses once. So your answer is yes, it is a function. Let's graph B. Here is what it would look like if I drew a vertical line. Is there any way that it would cross more than once? Let's see. Nope, crosses once. Nope, crosses once. Oh, wait a minute. Right here. Now this is not entirely vertical, but it crosses here once. The value of 0 cannot be both 2 and negative 3, so therefore, this one is not a function. So now I want you to look at the practice problem on 3 and 4. Look at them and just do them on your own. Number 3 would not be a function. It crosses at negative 1 on the x-axis at both 1 and negative 1, which cannot happen. It's not a function. Number 4 is a function. The third thing you're going to learn today is, once again, really easy, but students find this confusing. So look at the gray box in the middle of page 137. You have seen functions represented as equations involving x and y, such as y equals negative 3x plus 1. Below is the same equation written using function notation. And here's how you read it. F of x equals negative 3x plus 1. Please note that f of x and y are the exact same thing. So let's finish reading this box. Notice that f of x replaces y. It is read f of x. The letter f is the name of the function, not a variable. F is not a variable. Function notation is used to emphasize that the function value f of x depends on the independent variable f, or x. Other letters besides f can also be used, such as g and h. Now right now you're probably like, I have no clue what this even means. That's okay. It's really super easy, but it takes a little bit to get used to. F is not a variable. It is not like f times x. That's not multiplication. It's just the name of a function. So let's look at the got it, and maybe this will help you. The got it problem says use the function w of x equals 250x. All this means that this is a function where w depends on what x is. So it says This problem represents the number of words you can read in X minutes. How many words can you read in 6 minutes? I'm not even joking, this is how easy it is. You take the 6 and plug it in for X, but this is how you write it. Normally, this is what you would have done. Remember, X is the number of minutes. Y is the number of words you can read. So what would have happened in the past? How many words can you read in 6 minutes? All you would have done is this. You plug in 6, you take 250 times 6, and you would have gotten 1,500 words. Okay, it's the same problem, exactly the same, except instead of Y, you're using function notation. So here's what you're doing. W of 6, when you plug 6 in for X, you're actually putting it in here. This does not mean 6W. This does not mean 6 times W. All this says is the function W when X is 6. It's going to look like this. So when W of 6, that's going to give you 1,500 words. That's it. So flip the page to page 138, practice A number 5. You are buying orange juice for $4.50 per container and have a gift card worth $7. The function f of x equals $4.50 times x minus 7 represents your total cost. F of x, your f of x is your total cost if you buy X containers of orange juice and use the gift card. How much money do you pay to buy 4 containers of orange juice? All you're doing is we want to know 4 containers of orange juice, so I put f of 4 equals, and then I just plug in 4 for x. So you would take $4.50 times 4, and then subtract 7, and that would give you f of 4 would be $11. So instead of y equals, we're doing f of 4 equals $11. Go ahead and try number 6 on your own. And if you did number 6 correctly, the answer would be about, or approximately, 5,580,000 miles. Now obviously I rounded, and that's okay if you did not. Alright, the last section is finding the range of a function. So let's look at the got it. At the bottom of page 138. Once again, super easy. The domain g of x equals 4x minus 12. And then it says the domain are the following numbers: 1, 3, 5, and 7. We want to know what the range is. Now this is incredibly easy, and you're like, wait a minute, I have no clue what you're doing. That's okay. All this would be an equation, like y equals 4x minus 12. Here are all the x values. Find the y's. It would be like I gave you this equation here, y equals 4x minus 12, and I made you do a t-table with the x values as 1, 3, 5, and 7. All I do are plug in 1, 3, 5, and 7 to that equation to find y. That's all you're doing. Except you're writing it in function notation. So all I have to do is plug in the 1. Plug in the 1. 4 times 1 is 4. Minus 12 would be negative 8 is my first range. Plug in 3. 4 times 3 is 12. Minus 12 is 0. Plug in 5. 4 times 5 is 20. Minus 12 is 8. 7 times 4 is 28. Minus 12 is 16. You will notice that this is a linear function because each of these numbers are increasing by 8. That's it. That's your answer. Plug them in and you get your set range. The range is the set negative 8, 0, 8, and 16. We are going to now do problem 5 on page 139. You don't need to write any of this down, like the actual problem. I do want you to write the answer. But while this looks like a really difficult problem, I promise you, there's not much to this. What we are determining is a reasonable domain and range, which means you have to use common sense to determine what could my answer be. So here's our problem. You have 3 quarts of paint to paint the trim in your house. A quart of paint covers 100 square feet. The function A of Q equals 100Q, represents the area A of Q. So A of Q is your area in square feet that Q, which represents quarts of paint covered. What domain and range are reasonable for the function? Now remember, your X is what you plug in, your Y is what comes out. Now in this problem we're using A and Q. Your Q is the quarts of paint that you use. The A of Q is the area of paint that is covered. So Q is what you plug in, A of Q is what comes out. Now if you make a T table, your Q is the number of quarts, A of Q is the area. How many quarts of paint do you have? You only have 3. What's the minimum number of quarts that you could use? You could use 0. Could you use -1? No, you can't have -1 quarts. But you can go up to 3. Now, why can't you go over 3 quarts? Because that's what you only have. You only have 3 quarts. You can't paint more than the paint you actually have. So all we're going to do is plug in 0 to 3. So 0 would give us an area of 0 squared feet. 1, which is 100 times 1, that would give you 100 square feet. 2 would give you 200 square feet. And 3 would give you 300 square feet. So you have to understand that your quarts of paint are going to be any amount of paint from 0 to 3. Now you can't just have 0, 1, 2, and 3, because you could use a half a quart of paint or a quart and a half of paint. So this is how you'd write it. Your domain. Your domain would be 0 is your smallest, so your quarts have to be greater than or equal to 0, but less than or equal to 3. We have to write a conjunction. Your range, the minimum is 0, the maximum of 300. So we know that our area, which is A of Q, let's write that a Q here, A of Q has to be more than or equal to 0, but less than or equal to 300. Remember how you can read this? Domain is 0 to 3 inclusive, range is from 0 to 300 inclusive. So remember the 5 things we learned today. The first thing you learned is how to identify functions using mapping diagrams and domain and range. The second thing you learned is the vertical line test. Problem 3, what you learned is how to evaluate a function with function notation. And problem 4 is finding the range of a function. And lastly is the reasonableness of your domain and range. Table here.